I'm from Babaji's Flying School. I'm Plainwala. Today we are doing aircraft general. Aircraft general, small topic. From the notes I have here, small topic. Few things you have to learn about. Uh, I don't know if I'm going to be showing you all the FCOM or not. Still have to decide because it's FCOM. You know, can't show it. Anyways, uh, can yeah, I'll try to explain as much as I can on the notes kind of thing, and then we'll see ahead how everything goes. Okay, so aircraft general. I'm going to give you basics about the aircraft because each MSN to MSN, the aircraft is going to kind of shift around 319s, 321s, 320s, and they're going to have different dimensions and all. So I'll give you like rough numbers, which will help you like work with, and you'll be able to understand what the hell is going on with the aircraft. Then I'll be going through even the golden rules, cockpit philosophy, fly-by-wire, then few things about the FCOM like your abnormal procedures, your QRH, what the title bars and all come. And Air India's attempt, which happened in 3rd of this month, that they had asked us about these few questions. Okay, some people don't find it important, but I think so. Those 2-3 marks might be the reason why I cleared. It might be the reason why you clear. So just like keep it in your mind, in the back of your mind, that small things get asked. Anyways, let's continue with aircraft general. Yeah, mic is on. Okay. Okay, so try to understand aircraft general is what do you see about the aircraft from outside. So let's try and break it down like that. It'll be easier for you to visually connect these things. Okay, so what do you see? Okay, you know uh, the aircraft has swept back wings. I'd highly recommend for you to what do you call learn what's the benefits of having a swept back wing, because this helps you in your interviews. They'll ask you what is a swept back wing, how is it useful. They'll ask you what's a Dutch roll, how is a swept back wing affecting a Dutch roll, and yeah, they're going to ask you like questions based on those things also. So it's important that you kind of read up on these small things, because it's your aircraft at the end. Swept back wings means the wings are a little tilted towards the back. Okay, then we have dihedral. So that means your wings, one second, let me just pull up the correct image. Then it is like this, but let me see. Dihedral. It's like this, so it's got an angle up, right? Yeah, that's dihedral. Okay, so it's kind of yeah, it's a little pushed up in the air, you could say. Okay, try to find out why is dihedral, anhedral, what's the purpose of it, and why is it useful. Okay, okay. Okay, it provides stability. Okay, the dihedral wing. So you'll need to know all these things they're going to ask you on. Okay, it's a low wing aircraft. Okay, it's a low wing aircraft, meaning if the fuselage is above, like the wings have been placed at the bottom part of the fuselage. Okay, uh, you need to find out what is the difference between a low wing and a high wing aircraft. How does it affect your stability of the aircraft? questions get asked on that. Okay, another thing which we have are two cargo compartments. Okay, we are not including the bulk cargo. Are we? uh, I don't think so we are including the bulk cargo. So you have aft, forward and bulk. Okay, I think so aft and forward is just the doors. Okay, and then you have a bulk cargo. Okay, when we go into cargo compartments chapter itself, you will start to realize that the doors also open in certain directions, and it'll help you, like if you know where the door opens, in case your outflow valve later on in pressurization, if you have any problem, you can open one of these cargo doors and depressurize the aircraft. You can also depressurize the aircraft through the avionics, but it's going to take time because the avionics has a very small hole to depressurize through, whereas the cargo, big huge thing, it's hydraulically actuated. You don't need anybody right next to the cargo compartments. So anyways, we'll come to that chapter later. And then let's do a few things about speed, range, uh, basic stuff about the aircraft, how many pilots required, all those. Okay, so this was what the aircraft looks from outside. Okay, now we have 320 is subsonic. Okay, medium ranged. Okay, two pilot operations with one observer, civil transport aircraft. So if you see the FCOM has it in different lines. This like kind of just smashes everything together and you get it in one go. Okay, subsonic, so you know your speed, medium range. Okay, two pilot operations, one observer, civil transport aircraft. Okay, now approximate dimensions. So easy way to remember the dimensions, you could say the wingspan comes around 111 feet. Then you have height, which will be approximately 40 feet. Okay, now height out here means the entire height till the tip of the rudder. Okay, till the top, till the vertical fin cut top will be 40 feet. Okay, later on you'll be asked a few questions on this, but yeah, till the tip of the rudder it is 40 feet, and length 123 feet. Okay, there are unpressurized compartments in this aircraft. Okay, now few questions get asked on this, okay, during your interviews. So you have the radome. Okay, the radome, why is it unpressurized? That's going to be your next question. Okay, the radome is unpressurized because you're going to have your weather radar in there. Okay, so and the weather radar works depending on how far it depends on detecting water droplets. Okay, so you cannot have that area pressurized, because then basically you are first checking that environment and then you check the environment outside the aircraft, the atmosphere outside the aircraft. So the idea is you keep it unpressurized out there so that you'll be able to scan through everything fine, and you'll be able to detect moisture and your water droplets outside the aircraft. So your radome, for you being able to use the weather radar, that's why it's not pressurized. Then you have the nose gear bay. Okay, and the main gear bay. Okay, now these two areas anyways are going to open. Okay, pressurizing these two areas doesn't make sense because I have to open these doors and anyways remove the landing gears and everything. Okay, so there is no point in pressurizing these areas, because the gears itself are going to be taking a huge load when when you land the aircraft. So the gears are anyway strong. Okay, so they are anyways made stronger so that they can handle this pressure differential and all. They are designed to handle it. Okay, think of it like that. Then you have your air conditioning compartments. Okay, uh, now if you need to pressurize the aircraft, you need air to come in from somewhere, compress that air, and then send it to the aircraft itself, right? So obviously that area is going to be unpressurized because he is doing the pressurization. Okay, so that's why you could say the air conditioning compartment, that's your packs, have it's unpressurized. Okay, then you have your last few, which is your tail cone. Tail cone is a large area, and your safety valves have been placed in your tail cone. So the idea of the tail cone is also that in case there is a differential pressure buildup, the fuselage is just like one big huge cylinder. So in case that cylinder is too pressurized, the safety valve will open and it needs to depressurize the aircraft. So it depressurizes it within the tail cone itself, and the tail cone is also a large area which saves fuel. It makes it more fuel efficient also, that the aircraft is getting pressurized out there. Even in the tail cone you have your APU, which is just like a small little generator out there, which is it's like a small engine out there which is running, and it's using the unpressurized air from outside to run itself. And it also produces what you call bleed air and everything, which is your pressurized air. It will also be producing later on. So there are multiple things going on in the back of the tail cone. It saves fuel cost to not pressurize that area also. And anyways, you have kept a small generator also out there. It helps also keep your safety valves also out there. There are a lot of reasons for the tail cone. Okay, then we have our last one, which is the question which they ask is, why is cargo pressurized? Okay, why is cargo pressurized? So the idea is, supposing this was a fuselage. Okay, so the passengers were on top and cargo was below. Now the idea is, if I have to anyways make the entire structure strong, the fuselage has to be strong. Okay, because it needs to carry the cargo and the passengers safely. Okay, so the fuselage itself is designed to handle the pressurization. The passengers and the cargo have just a floorboard, which makes sure that the pressurization it's like there's a floorboard between the passengers and the cargo, you could say, and not could say, that is. And the sorry, I'm keeping on getting derailed. The idea is, if I leave the cargo unpressurized, then I have to increase the strength of the floorboard. Okay, because the floorboard should be able to handle the differential pressure, and the fuselage has already been designed in such a way that it can handle the pressure anyways. So to save fuel and save costs, what they have done is, because increasing the strength of the floor would mean I have to put more material on the floor. If I have to put more material on the floor, the weight of the aircraft is going to increase. Otherwise, if I'm going to put some composite expensive material which is light but will provide strength, that's going to be also expensive. So anyways, your what do you call, cost of the aircraft is increasing. So it's like a cost saving kind of a thing. And your cargo anyways, sometimes if an airline needs to transport animals, some airlines transport animals in the cargo compartment, the animals are kept, and they get transported. So it's a good option to have also, in case you need to like make your airline flexible, and it saves costs. It's like mass production is going on of these aircraft, so that's why the cargo compartment is also pressurized. Okay, then we have so it's kind of fuel consumption. Okay, then we have few basic things about the runway. Runway width, what you need to do a 180. Okay, so if I need to do a 180 turn, I'll need 24 meters of turn width. Okay, then I can do a 180. Okay, for wet runways it's going to be more. If the runway is wet, it'll be much more than not much more, it'll be more than 24 meters for sure, because again you need to turn, friction's going to take a little part in it, your radius might increase and then become like that. Okay, next thing is your tail strike awareness. Okay, so tail strike awareness for takeoff is 11.7 degrees and for landing it is 13.5 degrees. Okay, now the idea about this is people will say ki Airbus has said ki every second you can do 5 degrees for 3 seconds. Okay, or 3 degrees per second for 5 seconds. Okay, so you get 15 degrees as a total. That is over time limit. So what happens is when I'm taking off, it takes me if I do in the first second I do 3 degrees, I still gain a little height, then I do on 3 more degrees, I still gain a little more height. I'm gaining height as I'm increasing my pitch. These limits, awareness limits, are if you immediately do the rotation at these limits, you're going to have a problem. Okay, otherwise Airbus has said 3 degrees per second for 5 seconds. Okay, so you can do an immediate pull to 11.7 before you get a tail strike, or when you're doing a landing 13.5 before you get a tail strike. Okay, now let's talk about your eye level. Okay, this is where they'll ask you know that the aircraft height is 40 feet, but your eye level is going to be 15 feet. Okay, your eye level is 15 feet. So when you are, let's say this is 15 feet. Okay, this is 15 feet. So the idea is when I am seeing from the cockpit, I will have a cutoff angle of 20 degrees. Okay, so if anybody asks ki how far you can see, the minimum like distance you can see is 41 feet away from you. Okay, like ground you can actually see would be 41 feet minimum away from you. Okay, below 41 feet you won't be seeing what is below you. Okay, so that's one thing to know ki if anybody asks you what's the minimum distance you can see, you can go down till 41 feet. Okay, you can't say I can see 10 feet ahead, because you actually can't see the floor 10 feet ahead. You can minimum see 41 feet ahead. You are like then sticking your head out of the window and then seeing the ground. Okay, so basically this area which I've marked is an obstructed view. Okay, so this part is important for when you're doing taxi during low visibility. Okay, that time it's important. Okay, now next thing are your golden rules. Okay, golden rules, you need to know it word for word, because if you don't know it word for word, let's just say your interview is not going to go well. Okay, these 4 rules you need to know it very very well. Okay, you word for word, you can't even substitute words which have the same meaning. Okay, oh god. Okay, so what are the what do you call golden rules? We have 4 golden rules, very simple, very straightforward. Okay, first one, very obvious. Okay, what do you think it's going to be? You can pause the video and then you can say it out and then we'll check. So some of y'all might have said aviate, navigate, communicate. Aviate is wrong. That's where they catch you. Okay, it's fly, navigate, communicate, Then what is the order that you will do everything? In this only order you're going to do it, and you're going to do it with appropriate task sharing. So it's not going to be you doing everything. Okay, you try to reduce workload so that you can pay attention to what is your job. Okay, so fly means my role, my speed, my thrust, okay, my pitch, all these things. Navigate is what? Navigate is going to be, where am I going? Okay, am I going into a mountain? Am I going into a building? Am I on the correct heading? Is my aircraft going towards some other city or something? So you get like spatially aware you are. Where am I in the airspace? Okay, communicate with who? Some people will be only thinking communicate with the ATC. The ATC is not flying the aircraft. You and your co-pilot are. Okay, you and the captain, or you and the first officer. Most probably you guys are going to be fresh TR guys who are seeing the video. So you and the captain. So you need to communicate with the captain what you are doing. The captain will communicate with you whenever he can to tell you what he is planning to do. Okay, so you're communicating with first the person next to you, then you are communicating with the people who are looking after the passengers. Okay, so that's the cabin. The cabin also has to know what the hell is going on. Okay, you have to communicate with them, have everyone coordinating because it's a team effort. Then in your team you also have your ATC. The guy out there is there to help you also. So he will be then guiding you. He'll be clearing airspace, he'll be guiding you where to go. He'll be like, you can give like sub delegate work throughout. Okay, so you as a pilot, it's not everything is falling on your shoulders. Sub delegate the work, even it out, use the resources at hand. Okay, so again, fly, navigate, communicate in this order and with appropriate task sharing. Okay, so you'll always notice that there's a caveat at the end of everything. It's like a small little trick to each like it is not just fly, navigate, communicate. We have also this in this order and with appropriate task sharing also. Okay. Then the next one, we have use appropriate level of automation at all times. Okay, now try to understand what they are trying to say out here. Use appropriate levels of automation at all times. If let's say I have a pressurization fault, okay, I'm not going to cut my auto thrust out just because I have a pressurization fault. Okay, use how much automation you can. Okay, if I have to control the pressurization part manually, I'll control that manually. Why should I leave everything else? Okay, the autopilot is really doing a really good job. It's designed very well. So let it do its job. You monitor it, you make sure that it's within limits, but you make sure that it doesn't go out. Okay, out of this thing. Okay, so use appropriate levels of automation at all times. Then if you notice, one of your memory items also, for emergency descent, it uses automation, but later on you will learn that your speed brakes on autopilot will deploy only 50%. They do not 100% deploy. So like 50% deflection. So then people will ask, why not? You want to do emergency descent, you want to descend fast. You're actually getting a very good descent rate in with just 50% deployed also. Okay, you don't need to knock off the automation for no reason. Okay, the aircraft will be able to handle it. If you need to knock off the automation, you can knock it off, and then you'll get a faster descent rate. You can still get a higher descent rate with the autopilot by putting down the landing gears also. There are so many things before knocking off the automation. So it's always use the what resources are available. Again, it's somewhat boiling down to that, but remember it as appropriate levels of automation at all times. Okay, now the third one is understand the FMA at all times. Okay, so understand the FMA. So whatever automation I have been doing, your flight mode annunciator is going to be telling, he'll be announcing key, okay, these things is what the automation is doing. Okay, this is what the aircraft's mode is, it's in, this is what the aircraft is doing. So you need to not only know how to run the automation, you even need to know how to understand and read what the aircraft is trying to tell you through what it's doing in its automation. Okay, so that's why it's important to understand the FMA at all times. Okay, it does not say read the FMA at all times, it does not say dictate the FMA at all times, it does not say the FMA at all times. It says understand the FMA at all times. It wants you to know what you are doing, it wants you to know what the aircraft is doing. Okay, what you have said, what the aircraft has understood from what you have said, like that, that's how you'll understand the FMA is the next important thing. Then we have last one, take action if things do not go as expected. Now supposing you do a botch up or the autopilot does a botch up, you don't let it keep on getting worse. You take action, you correct it, and you continue. Okay, because you have to be, as you remember, you have to be 5 minutes ahead of the aircraft. You should know what the aircraft is going to do before the aircraft does it. Okay, so take action, try to always be on like, don't try not to hesitate to do anything, because the more you hesitate, the more time you're wasting. Okay, just to build up courage to do something, you'll be wasting time. Try to understand what is going on and then take action. Okay, if you notice that the aircraft is going into a roll, okay, you just don't let it go into a roll for no reason. You don't want a roll and it's going into a roll, you don't let it go into a roll for no reason. You take over controls and you correct it. Then you check why was it going into a roll. Okay, you check, was it the automation, was it the other pilot next to you, what was the reason. Okay, so take action if things do not go as expected. Then we have dark cockpit philosophy. Okay, it's pretty simple. If the aircraft is dark, that means there's no lights in the aircraft. It means the system is ready and fit to fly. Okay, that is the point of dark cockpit philosophy. Then you have fly by wire. Fly by wire is that the aircraft is not mechanically linked. Okay, your controller sends a signal, an electrical signal to an actuator, which is nothing, it's like a hydraulics kind of a thing. Okay, and that actuator moves the surface. Okay, that's the point of the fly-by-wire. Now fly-by-wire, it reduces weight. Okay, because mechanical linkages, those big linkages have been removed and just wires have been kept. Okay, it, because weight is reduced, your fuel consumption has reduced. Okay, okay, then your maintenance of the aircraft has been reduced, because you don't need to keep on changing these big mechanical linkages also. So maintenance also has also reduced. Then you have increased accuracy, because the electrical signal will be much more closer and accurate to what you actually want, and then the actuator will know exactly how much pressure to push in, or how much to deflect the surface. Okay, and lastly you have improved redundancy, because you can have multiple computers now, because the weight is technically reduced. You can have multiple computers, multiple sets of wires, and it'll ensure that there is safety on the aircraft. Okay, now we have overhead panel color coding. Okay, so overhead panel has a color coding, and basically the overhead panel has a button which is split into two parts. Okay, so the upper part is usually to indicate a fault, okay, basically a status is the top part, status is the top one, and the if there is no status, there'll be two gray dots. Okay, and the lower one is for your selection of your control. Is it on, is it off? Okay, again it'll be replaced by two gray dots if it's not in use. Okay, fcom layers. Now fcom has layers. Okay, you'll notice it'll be written L2, L3, L1. L1 is a default layer. If it's not, if there is no layer mentioned, it is L1. Okay, default is need to know. Okay, you need to know this information. L2 is nice to know. It's like okay, ठीक है, ऐसे काम करता है, ठीक है. It's like how it works. Okay, how does the thing work? Works like this. Okay, it's nice to know. Okay, it's not going to actually affect. L3 is not required for your flight operations. Okay, so it's not necessary for flight. Okay, it's just additional information. Okay, it's detailed information. Now we have something called OABs. Okay, OABs are, y'all can guess the full form? Yes, I didn't know it myself. First word was what was confusing me. So it's operations. Okay, it's operations, engineering, bulletin. Okay, so it's operations, engineering, bulletin. Okay, it is given by the manufacturer. So Airbus might realize that okay, this MSN or this set of aircrafts has a certain problem with it. Okay, so they'll issue an OAB because it's not all of the aircrafts. It's just a certain, like 25 aircrafts have a problem. One aircraft has a problem. Okay, they'll issue an OAB, and in the OAB they'll tell you, okay, don't worry, you might face such a failure or such a problem. This is the procedure to go through the problem. It'll rectify it. Okay, so it can be very specific to a particular registration, and it's a temporary procedure. Okay, now you have two types of OABs. You have red OABs and you have white OABs. Okay, so what is red OABs, what is white OABs? Red OABs has, again, like abnormal and emergency ka thing, red OABs has significant impact on safe operation. And the other white OABs does not have a significant impact on safe operation of the aircraft. Okay, red needs to be given immediately. White can be sent to the flight crew in 30 days. Okay, flight crew can get it in 30 days, the white one. The red one has to be sent immediately to the flight crew. Okay, this is the issue. Please make sure you'll follow this. Okay, now MEL conditions. Okay, MEL conditions arise depending ki whether you can dispatch an aircraft or not. Can you fly the aircraft with certain things that are failed? Okay, so MELs you will always refer to until takeoff thrust is set. Once takeoff thrust has been set, MEL cannot be referred to. Okay, now MEL has this thing where it has O or M written next to it. O is operational procedure, that means the flight crew can do it. Okay, M means maintenance procedure. Okay, so that means you'll have to take it back to the bay, and then the maintenance guy will fix it. Okay, he will do the reset. Operations means you can do the reset. Okay, so MEL has MEL conditions. So whenever there is a condition, they'll give you a situation like something's happened, and then they'll give you a condition. You can take off if you do these things. Okay, then you have, so that's a normal case MEL. You'll have a situation and condition. Okay, then you have no dispatch. No dispatch means you cannot dispatch this aircraft. Okay, it's a no-go. Okay, no-go with this particular system faulty. Third one is not related to MEL. Example is I've put takeoff thrust, but my parking brake is on. It's not related to MEL. The operations should know that, oh my god, I've left the parking brake on. It's a stupid mistake. People do make it. Okay. I've made it in my sim session once, and oh my god, the instructor he never left it. Every time I used to meet him, I used to be like, yeah, this time you release the parking brake and then try to take off, and I was like, yes, please, sorry. Okay, so yeah, that is a point of not related to MEL. Now finally you have repair intervals. Okay, promises is the second last part, and then we are done. Okay, repair intervals. Okay, it'll be written A, B, C, D next to it. Okay, A means there is no standard interval. B means 3 consecutive days you should do the repair. Okay, C is 10 consecutive days, and D is 120 consecutive days. Okay, these are calendar days, so you don't do business days and all that. This is not like a post office. Okay, Sunday it's closed or something. No, consecutive days every day is counted. Okay, you can't say, okay, I have Independence Day today, so closed. Okay, yeah, now we are done with this. Finally, we are at procedure titles. Okay, procedure titles is basically on your FCOM, and the procedures you'll have a title like this. Okay, so sometimes this edge boxes are there, sometimes they are not there. Okay, so in amber cautions, if you notice, you'll have a white background okay, and it's just ecam title on a white background. Okay, so this is basically, it's like this is white, and you have your title. Okay, title will be in yellow. Okay, I'm sorry, I'm too lazy to do this color changing and all, and the timer showed me like 40 minutes of video. Anyways, next we have is red warning. Okay, this will have like this boxes. Okay, we'll have a title. So background is white again. These two boxes are red. Okay, and the title is also red. Okay, then we have QRH abnormal procedure. Which is title, which is in gray background. Okay, then again QRH, let's say, what is it, emergency. You'll have it again in gray background, gray. Okay, and oh shit, sorry, the background is gray, these two boxes are red, title is also red. Okay, title is, yeah. Then you'll have again one last thing, which is QRH summary. Sorry, I'm getting a lot of messages right now. I need to finish this chapter. If you're in summary, then you'll have gray boxes. Okay, gray or black boxes, let's say black. Okay, black boxes, you'll have white background. Okay, and here you'll have your title. Okay, conditions that are given on your FCOM, you'll have a black square. Black square is what do you call, starting point of each procedure. Okay, black dot is a condition. Okay, dependent on this condition. Okay, it's a precondition. Okay, then you have indentation. That means it's written a little to the side. Okay, then at that time it depends on your whether indentation means it's like part of the precondition or something. Okay, part of a precondition or procedure. Okay, and last is boxed items. Okay, boxed items are important, they are memory items. Okay, otherwise they can be at any time of the procedure. It can be OEBs. Okay, that's what boxed items are. Okay, we are done with aircraft general. Please do this properly because few questions come, Air India questions that come, which was based on this. What do you call? What's the black box for? Then we had another one, I think so. Yeah, there was one dark cockpit, I think. No, FCOM layers L2. That was one more question. Okay, so please do this properly. Tomorrow I'll be covering, like the next video we'll be covering is air conditioning, and I might show you a few schematics from the FCOM. Okay, thanks guys. Bye. And like, share, subscribe, uh, comment in case I have said something wrong, and correct me. Okay, thanks guys.